That sleek phone in your boardroom may be doing more than handling calls. During an authorized network test, a standard packet sniffer can capture an unencrypted provisioning handshake and expose administrative credentials in readable text. The phone does not need to look infected. It may simply be following its normal setup process. I am going to show you how that quiet exchange can turn one trusted office device into a path toward the rest of the company network. Most owners and managers think cybersecurity means firewalls, suspicious emails, and strong passwords. Those controls matter, but they can pull attention away from hardware that appears ordinary. Phones, conference systems, and other smart office devices are computers connected to the network, even when nobody treats them that way. The desk phone is a perfect example. Mobile devices dominate many conversations, yet dedicated VoIP phones remain common in offices and executive boardrooms. They look fixed, limited, and predictable. That appearance creates trust. The risk begins behind the screen. To make deployment easy, a phone can automatically search the network for the server holding its configuration. That background conversation may reveal where management systems live and, in the scenario we're examining, the credentials used to reach them. First, I will translate that invisible handshake into plain English. Then we will look at what the captured information can expose. The most important part comes after that, because the real danger is not control of the phone. It is where the phone's trusted access can lead. Finally, I will give you a practical audit and hardening checklist you can take directly to your IT team, person, or contact. Let's start with the moment the phone joins the network. The first surprise is that the phone may announce what it needs before anyone places a call. Think about a new employee arriving at a hotel. Instead of already knowing the room number, the employee asks the front desk, identifies who they are, and receives directions. Automated phone provisioning works in a similar way. The device connects, looks for the appropriate service, and requests a configuration that tells it how to operate. That convenience is why an IT team can connect many phones without manually programming every single unit. Plug it in, let it find the centralized server, and allow the setup process to handle the repetitive work. The weakness appears when part of that conversation uses a legacy broadcast behavior without encryption. A broadcast is closer to speaking across a room than whispering to one person. Other devices on that network segment may be able to hear it. Encryption would make the content unreadable to an observer. Without encryption, a network capture may display the exchange as it happens. A packet sniffer is simply a tool that observes network traffic. In an authorized security test, it lets us examine what devices are saying without relying on what their marketing pages promise. We are looking for the moment the phone requests its identity or configuration from the centralized server. The phone may look idle during this process. There may be no warning on its screen and no obvious interruption for the person sitting beside it. The meaningful activity is happening in the background. That distinction matters for managers. The issue is not necessarily an employee making a mistake. The device can expose information while doing exactly what it was designed to do. Legacy packet behavior can also remain present in modern deployments and firmware. So a new-looking phone is not proof of a secure setup. Once that handshake is visible, the next question is unavoidable. What is traveling inside of it? Here is where a routine setup message becomes a security problem. In the captured traffic from this scenario, the useful packets are separated from the surrounding network noise. They point toward server login paths and administrative credentials associated with provisioning. Most importantly, those credentials appear without a meaningful layer of obfuscation. They are readable rather than protected ciphertext. For those who don't know, ciphertext is what properly encrypted information looks like to someone who does not have the key. Meaningless characters with no practical value. Plain text is the opposite. If a password is transmitted as plain text, the observer does not need to crack it. The secret has already been translated for them. This does not mean every office phone exposes every password. It means hardware using this kind of unencrypted legacy process can leak sensitive access information, and you cannot judge that risk by the device's price, age, or appearance. So why would a system behave this way? The design pressure is convenience. Manufacturers and administrators want phones to be easy to deploy. Automatic discovery and centralized provisioning reduce setup time. But when plug-and-play behavior is built around weak credential handling, operational convenience can come at the cost of secure defaults. There is another reason this can survive unnoticed. Teams often monitor servers and employee computers more closely than fixed function hardware. A laptop requesting unusual resources may draw attention. A desk phone talking to a provisioning service looks expected. The activity blends into the normal environment. The capture can also be passive. Observing an exposed handshake does not necessarily require changing a file on the server. That means the absence of a server error or obvious user complaint does not prove that the credentials stayed private. At this point, it is tempting to call this a phone problem and replace one device. That response misses the central risk. Credentials are valuable because of what accepts them, not because of where they were found. And that takes us to the biggest revelation. The phone is not the final target. It is the starting point. The credentials exposed during provisioning may open access to a broader network management interface. That changes the scale of the incident. We are no longer asking whether someone can alter a phone setting. We are asking whether credentials trusted by management systems can help an intruder move from one network resource to another. Security teams call that lateral movement. Imagine someone entering an office building through a neglected side door. The first room may contain nothing important, but if a key inside that room opens the corridor, the elevator, and additional offices, the side door was enough. A similar path can begin with one desk phone, continue into a management service, and move towards central identity infrastructure such as Active Directory. Active Directory is the system many companies use to organize users, computers, permissions, and access. Reaching toward that environment means the potential impact is no longer limited to calls. This is the twist owners need to remember. The least interesting device in the room may hold the most interesting route through the network. Now we can map why that route is so often overlooked. The attack path works because people often confuse familiarity with safety. A desk phone does not look like a traditional computer. It usually has no keyboard, no browser window, and no employee downloading attachments. So it falls into a mental category called equipment rather than computing. From the network's perspective, that distinction is misleading. The phone communicates, receives configuration, stores settings, and relies on services and credentials. Physical location adds another layer of false confidence. A premium phone inside an executive suite feels controlled because the room is controlled. But the network trust is not created by expensive furniture, a locked door, or the job title of the person using the device. If the phone shares a network segment with systems it does not need, its placement can create unnecessary paths. This is why focusing only on the visible compromise is dangerous. Replacing the phone might remove one symptom, while leaving the same provisioning method, shared credentials, and network design in place. Another device using the same process could recreate the exposure. The useful way to map the risk is as a chain. First, the hardware connects. Second, it uses an automated discovery or provisioning process. Third, an unencrypted exchange reveals information. Fourth, the exposed credentials are accepted by a management interface. Fifth, that access creates an opportunity to move toward broader identity or administrative systems. Every link does not have to fail in every company. The point of the assessment is to learn which links exist in yours. If provisioning is encrypted, credentials are tightly limited, and the phone network is isolated, the route becomes much harder to use. If the device is broadly trusted and shares access with important systems, the route stays open. So the right question is not, do we trust our phones? The right question is, what can a phone reach? What secrets does it receive? And what happens if those secrets are observed? Those questions lead directly to the fix. The fastest improvement is to stop treating every connected device as if it belongs in the same room. Network segmentation creates separate zones. VoIP phones and other chatty smart office devices can be placed in a segment designed for their actual job. Access between that segment and important business systems can then be limited to what is required. Think of segmentation as adding a controlled door inside of a building. Someone who enters the lobby should not automatically gain access to payroll, the server room, and the executive archive. In the same way, a phone that needs calling and provisioning services should not receive a broad route to unrelated management or identity systems. The second improvement is zero trust. Despite the name, it does not mean assuming every employee is malicious. It means access is not granted merely because a device is physically inside of the office or already connected to the network. Each request should be limited and verified based on what that device actually needs. That approach directly challenges the trusted device fallacy. A phone does not receive broad confidence because it has been sitting on the same desk for 5 years. Its permissions remain narrow because its function is narrow. The third improvement is secure credential handling. Audit whether legacy provisioning protocols are enabled. Check whether discovery and configuration traffic is encrypted. Identify the credentials used by those services and determine where else they are accepted. Administrative credentials should not travel in readable form, and a credential intended for phone provisioning should not become a general key to broader systems. The fourth improvement is verification. Do not rely on a settings page saying encryption is enabled. During an authorized audit, observe the actual network traffic produced when a phone connects, restarts, or requests configuration. The purpose is not to attack the company. It is to confirm that real behavior matches the intended design. Those 4 moves turn an invisible concern into a manageable project. Now let us put them into one checklist. Here is the audit I would give an owner, manager, or board member. First, ask for a complete inventory of VoIP phones, conference systems, and connected office hardware like printers and MFP devices. It's very difficult to protect devices nobody is tracking. Second, ask which network segment those devices use. Confirm that phones and other smart hardware are isolated from sensitive systems wherever direct access is unnecessary. Third, ask how each device discovers its provisioning server. Legacy broadcast and discovery behavior should be identified, disabled when it's not needed, or protected with encryption. Fourth, ask whether any usernames, passwords, server paths, or administrative details appear in readable network traffic. This should be verified through an authorized capture, not assumed from the age or price of the hardware. Fifth, identify every system that accepts the provisioning credentials. If the same credentials open a broader management interface, reduce their permissions and limit where they work. Sixth, map the route from the phone network towards central identity systems, including Active Directory. Your IT team or person or contact should be able to explain which controls stop that path. Seventh, review firmware and configuration together. Updated firmware does not automatically remove an enabled legacy protocol or repair a weak deployment choice. Finally, repeat the audit after major updates, hardware replacements, or network changes. Secure architecture can drift as new equipment is added. The goal is not to remove every office phone. It is to ensure that a device built for communication cannot quietly become a source of readable credentials or a bridge into the rest of the company. Inventory it, isolate it, encrypt its traffic, restrict its credentials, then verify the result. That is how you close the side door before someone discovers the keys behind it. If this gave you a better question to ask your IT team, like and subscribe. As always, thank you for watching, and we'll see you on the next one.